Welcome to Chapter 6, Security Operations and Administration. We'll explain the role of IT operations, the administration, and go over security policies. Some of our key concepts are the role of security administration, right, within the organization. How do we handle security, from an administration point of view? The components of the IT security policy infrastructure. How do policies enforce security? And we'll talk about that. Data classification standards used by the organizations and the DoD. Data classification is a huge area and a huge undertaking for most organizations. How do you classify all the data that's being created, every day, and then securing that data appropriately? Change management and configuration management. These play hand in hand with security. Always finding bugs and issues, but also the organization is constantly moving, constantly improving, constantly creating new applications and systems. And so that process of our change management and how do you engage security, how does security control all the changes and ensure that secure operations are continuing. And then configuration management, that goes hand in hand with change management, but you have your configurations and standards. Most of the time in larger organizations, things aren't done by hand. You have scripts and configurations, but you have different versions. And how you manage these versions? The system lifecycle, SLC, from the implementation of the project that brings on a new application. Stands up the systems and configures the application, gets the users using it, and then how do you retire the system, right? That whole system development life cycle. We'll talk about that, and how do we engage security, and how does security fit into that. So the first part is our security administration. And it's basically those that are responsible for planning, designing, implementing, and monitoring our organization's security plan. So these be your chief security officer and his team, and some architects, things of that nature. Those are the individuals responsible for planning, designing, and implementing your organization's security plan. And then they identify and document the assets, and then assign responsibilities, each one to a person or position. So controlling access, we have to first identify what our assets are and what needs access controlled, right? And then also, but then identification of who is trying to access this, right? And so in this scenario, we need to find out what user, right? What user account or who or what entity is trying to access a controlled asset. Then authentication, we verify that they are who they say they are, right? So say, for example, you go into a building and they have a security guard, you present them with your ID. That's your identification. Then the authentication is they look at your ID, then look at you and verify that it is you. And then authorization, they look through the list of available entry, people that have access to entry, and then they authorize you to enter. And then accountability is, they monitor you with cameras and that, or maybe even a guard goes with you and make sure that you're accountable for your actions in the building. So that's a non-technical way, right? For a technical way, the identification is your user account, the authentication is your password, authorization is the groups that you're in, what your account is in, that gives you access to a certain server or web page. And then accountability is the log files. What did you do while you were on the server or application? So documents, procedures, and guidelines. The most common documentation requirements includes, right, the sensitive assets, the organization security process. So what assets needs, must the organization take measures to secure? They can include computers, network components, databases, documents, and any other assets, and could be vulnerable to attack, right? And then how does it all work, right? Which administrator, who's responsible for or is authorized for what assets and what actions? Then what information needs to be communicated, how is it communicated, and when is it communicated? And an organization, must comply with rules on two levels, right? Regulatory and then the organization. Both of them will have compliance, and so the organization must comply with the laws and government regulations, and then you also need to comply with the organization's rules and policies and standards. Disaster assessment and recovery, right? So the leaders, your security administration team will handle the incidents, disasters, and other interruptions. The emergency operation group is responsible for protecting sensitive data in the event of disasters or equipment failure or other emergencies. Security outsourcing, right? So advantages, right? A security management firm has a high level of expertise because it's focused on security and security only every day. Simply put, it will have expertise and experience that your own organization may not be able to have or develop. So that is a huge advantage, and they'll cost less than having that expertise on your staff typically. And the larger you are, the less that is probably true, but the smaller you are, that is more likely true. But disadvantages, though, has two primary disadvantages. The first, you might not know your organization well enough and might not possess enough internal knowledge to really truly secure your environment. And then second, by outsourcing, you won't develop in-house capacity or talent, and will therefore need to continue to pay for this service forever, right? Outsourcing concerns, right? Privacy. Does the third party agree to uphold your privacy policy? How do they plan to control your data that's collected, stored, handled, and destroyed, right? How is that all handled by them? And especially with outsourced, it's got to be in the contract. If it's not in the contract, it doesn't exist, and they're not responsible. Risk. What additional risks exist by transferring data over to over a trust boundary? How are any new risks addressed? Who's responsible for managing the new outsourcing risk? Data security. What controls protect data confidentiality and integrity from unauthorized access? Are access controls consistent with the internal controls? How is data availability protected? Are backups and redundancy measures in place to minimize downtime? How are backups and redundant data copies protected? And then ownership, right? Who owns the data, the infrastructure, and the media? Who's responsible for each component? And then adherence to the policy. Who's responsible for enforcing it? How does it get enforced? And how can you enforce the outsourced employees to adhere to the policy? Is that in the contract, or what's the avenue if some of the outsourced employees aren't adhering to the policy? Common agreements, right? So service level agreement, or SLA, right? This type of agreement is a formal contract between your organization and the outside firm that details the specific services the firm will provide and how they will provide it. Will they have an hour response time or 4-hour response time, or 2-day response time, depending on the level of application or need, right, or whatever that service is. Blanket purchase agreement, a streamlined method of meeting reoccurring needs for supplies or services. A BPA creates pre-approved accounts with qualified suppliers to fulfill reoccurring orders for products or services. BPAs can be very helpful in simplifying the process of reoccurring purchases. This is very true at very large organizations where it could take months to get approval for purchases. So having a blanket purchase agreement already in place eliminates that time that's required and makes it so much simpler. Memorandums of Understanding, or MOU, is also called a letter of intent. A MOU or MOU is an agreement between two or more parties that expresses areas of common interest that results in shared actions. MOUs are generally less enforceable than a formal agreement, but still more formal than an oral agreement. Interconnection security agreements, or ISA, often an extension of the MOU. The ISA serves as an agreement that documents the technical requirements of the interconnected assets. This type of document is most often used to specify technical needs and security responsibilities of connected organizations. All right. Compliance. So event logs are records of actions that your operating systems or application software create, and monitors, or logs what users are doing as well. Compliance liaison, make sure all personnel are aware of and comply with the organization's policies. Remediation involves fixing something that is broken or defective. Professional ethics, right? So you set the example, demonstrate strong ethical principles in your daily activities. Users will follow your lead. If you're serious about ethics, your user will be more serious about ethics. Encourage adopting ethical guidelines and standards. So security professionals must know their ethical boundaries and set an example by adhering to them. This often means making difficult decisions and setting a good example. You must push the organization to defy its code of ethics. This helps the staff operate ethically and responsibly. Inform users through security awareness training and make sure users are aware of and understand their ethical responsibility. So, and just a code of ethics helps ensure professionalism throughout the organization. Personnel security principles. So you got limiting access, separation of duties. That's very big, right? So separation of duties means that you don't have someone that can create a purchase and approve the purchase, right? You want to have those two different people so that somebody can't get away with fraud or do things, right? Limiting access is, you want to limit access. Job rotation is kind of the same thing. You don't want somebody always approving certain things or doing something without having other people go into that job, because there's a possibility or potential for fraud if somebody's there in the job too long. And then mandatory vacations, the same thing. If an employee never takes vacation, there's a possibility that there's fraud going on, and they don't want to go because somebody will uncover what they've been doing, right? So mandatory vacations helps prevent fraud. Security training, right? A lot of times users do things they just weren't aware, right? So security awareness training helps set that standard and give guidance. What do I do if I find a USB in the parking lot? Don't plug it into the computer, right? But just making that security awareness, and then social engineering, trying to give scenarios, right, to help your users better defend against social engineering, because the users are really the weakest link in our security structure, our policies. So this is how IT security is structured within an organization, in any sizable organization. You have policies. They're at the top, right? So they're more general in nature. So something like you should use strong passwords, right? Standards should, they're the next come down. So policies are at the CIO and the CSO level. They're at the C-suite level. They're high level. Standards, they're a little more detailed, as in you should use a complex password, and maybe uppercase, lowercase, digits, special characters, and be 14 characters, right? That's a standard. Procedures is, this is how you implement a secure password on Windows. Then another procedure, this is how you implement that secure password on Linux. This is how you implement a secure password on a Mac, right? So those are procedures. They're more specific. They're detailed. Baselines, they're just like the minimum standard, right? And just give examples of that, and guidance gives you more examples and helpful hints, tips, tricks. Don't use your name or use usable words, something like that. That might be a guidance, but it's just going to be a little more helpful to help the users understand the procedures, right? Security policy environment, right? So you have the environment includes the overarching organizational policy, but those the regulations and from the government and laws feed into the policies, right? Because if there's a law that you must comply and keep health data encrypted at rest or something like that, you're going to need a policy that says that health data needs to be encrypted at rest, right? So that's going to feed into your policies. Your organizational goals will feed into your policies. Laws will feed into it, and shareholders' interest and organizational objectives all feed into the actual management overall security statement, right? So the policies are at that high level, which will help dictate and craft this management security statement. But it has all these inputs. And here is security policy hierarchy, right? So the statement by top level management, that security is important to the organization, and the objectives pursuant to a security state will be recognized, supported, and funded, right? Because that's important, right? You can say you want this, but if you're not funding it, or if leadership isn't really supportive of it, then you're going to have problems. That's why policies start at management, top level management level. Then you have the functional policies in support of the organizational policies. These are the actual policies, right? So you got to have the top level management buy-in to security. Then you actually have your policies, right? So your acceptable use, firewalls, other policies, right? And then the supporting mechanisms are your standards, your procedures, your baselines, and your guidelines. But really, from a practical standpoint, the standards, these are where auditors will audit and make sure that you're meeting the standard, right? Procedures is what the users need to use and actually implement or comply, and then the baselines is here's the minimum that you need to meet, and then the guidance is here's just some guidance on how to implement that procedures, why you're wanting to do this, and helping the users a little bit more. Data classification standards, right? This is becoming a bigger and bigger issue as we get more and more data, right? So classification is the duty of the data owner, because who else can identify and know what that data is, or someone the owner assigns, right? So somebody's got to understand the data, be able to classify it, and then you determine the value. You define the value of the information by several different measures: the value to the organization, the value to competitors, the cost of replacement or loss, the value to the organization's reputation, sensitivity, right? So sensitivity is the measure of the effect of a breach of the integrity or the disclosure of the information would be to the organization. So if it was lost or stolen, how bad is that, right? How sensitive is it? Organizations can measure sensitivity in many ways, including liability or fines, reputation, credibility, or loss of market share. And then criticality is the measure of the importance of the information to the mission of the organization. What would happen to the organization if the information were lost? And then the objectives of classification, right? So to identify information and protect the requirements, to ensure that the sensitivity and critical information is provided appropriate protections and controls, right? Lower the cost of protecting only sensitive information. You don't, public information you don't want to protect, right? You want it public. But your trade secret information, what your secret sauce, or your ability to have a market advantage, that needs controlled, that needs protected. And then how do you identify or label the data, right? And then you alert employees and other authorized personnel to protection requirements, and then comply with any laws and regulations. And then here are some examples of data classification. So the government, right, has unclassified, restricted, confidential, secret, top secret. In the private sector, we typically use public, private, and confidential. Configuration management, right? So this is the management of all changes to a system or device, and evaluates the impact a modification might have on security. And thus, as a security professional, it's our job to ensure that you adequately review all the system changes and ensure the configuration changes will not cause unintended consequences for security. Hardware inventory and configuration chart, right? So yeah, if you're rolling out a new patch or service, a release will be complicated if you can't find, update, and test every affected device, right? So knowing where your systems are and how to get to them and know what level of configuration they're at is very useful. And so having that up-to-date layout of the configuration hardware components, where they are, who has them, or where they're located, is critical. And then you need to also have somebody checking for vendor updates and service packs, right, and security issues, threats for the applications and systems that you have within your organization. Change management process, right? So configuration control is just the management of our baseline settings for a system or device. So you develop an application and you put it out in production. Those settings to get it out into production is called the baseline setting. It's the golden image, right? And nothing is supposed to change from that, and we're trying to manage and control any changes to that. So if we need to make an update, it needs to go through some formal change management process, so that people, including security, are reviewing these changes before they're made. So then change control management, right? You need to communicate the change management procedures and standards effectively so that the employees comply with it. Reactive management responds to changes in the business environment, and proactive initiates the change to achieve a desired goal. So you definitely want to be more proactive than reactive. But it does happen, right? The business needs to change, and so now we have to react versus a plan change where we know we're going to change, but we need to move that direction. We're going to switch our LMS. So like the college is looking right now proactively. Do we want to upgrade our LMS, or do we want to switch to another LMS that might offer different features and benefits for the organization? So we're proactively looking at it. Reactive is there's a huge security issue, flaw found, and now we need to make a change to implement that change quickly, right? So that's reactive. So you really love to be on the proactive side is more often than on the reactive, but you do have both, and it happens continuously. Change control committees or boards ensure changes are properly tested, authorized, scheduled, communicated, and documented. So regardless of it's reactive or proactive, it should go through a change committee process, or at least some change process to determine if it's a low, medium, or high change, and then depending on the type of change, depends on how much approvals does it need just the committee sign off, or does it even need leadership sign off? And so here's a typical change control process. You have a request to make a change, so we're going to say we're going to upgrade the LMS. We do an impact assessment, and it's like what's all involved, who could be impacted, what's involved, what's needed to do this. It goes through the change committee. They review our process and steps that we've implemented this is how we're going to implement the change, and they say, yep, you've done your research, and you have a good backup plan if something were to go wrong. They approve it, and so then you can start building and do your testing. You test in the test environment. You make sure what you've said is true, and work out any of the bugs. Typically, though, I'll disagree on this one. Typically, you'll have another approval process before you implement. In a lot of organizations, there's an approval process after your build and testing and you're ready to go into production, you'll have another approval process, because just to make sure that everything was done properly in testing. So the first approval is just, yes, you've got the go ahead and spend the money and build and do this, and you have a good understanding of what you need to do. The build and testing is you really learn what you need to do, and you get confidence that you can do it in production, and then you would have another approval process before you impact in production. In my opinion, you need that. Change control issues. Peer reviews. This ensures that a peer or another expert double checks all changes before you put them into production. Peers can often catch problems before they make it to the testing phase, right? And so that should be part of the approval process. Part of technically the committee should be experts as well, from every area that's signing off on this. In a good organization, in a good change management board, you've got input from experts that are reviewing what you're doing. Backup plans. Every change should ensure that if it doesn't work properly, you have a plan to restore, and to back out. You must have good backup plans and the documented backup plans. It just shouldn't say we'll just uninstall it. What do you have to do? Do you have to shut down service X and then change this configuration Y and shut down this service and pull out this card? You need to be detailed and specific in the exact step-by-step, how does it get backed out. And then documentation, it's extremely crucial that you document everything that you've done, and you should keep backup copies off-site as well for a disaster, right? So you should be able to have documentation that if your team were impacted, say you had a natural disaster and no one on your team would be available, somebody else from the outside should be able to read your documentation and be able to implement your systems, right? That's how they should be. And so we really need that documentation, and keeping that documentation up to date, that's probably one of the number one challenges. So application security, application software security, right? We have the system lifecycle, the system development lifecycle. So the system lifecycle, if you're buying a pre-bought application or hardware device appliance or something like that, you have the system life cycle of the purchase, installation, and then the removal when it's the end of life. System development life cycle is if you're developing your own application software, right? So then you have your development, testing, implementation, and then end of life, right? So, or maybe upgrades or end of life. And they're very similar, but just a few differences, right? The system life cycle includes the operation and disposal, and then and the software development life cycle actually does end in production. That's fine, and so. But it's just the development of the app. So you're in development and test, and then you go to production. Whereas the system life cycle covers everything from that development all the way to the disposal. Right. So here's one example of a system life cycle. The project kicks off. You get your functional requirements. What do you absolutely need the system to do? You design the system, you build the system, you do acceptance testing, It does work like it's supposed to. Then we implement to production. You transfer it over to the operations and maintenance teams, and then it's used for a few years, and then it gets replaced by a newer version, and so it's disposed of. Testing application software, right? You test for all expected and unexpected actions. You try to, do things that, anything that the user might do, even though you're not supposed to, right? And does the application handle errors correctly, right? So if you put letters in for your social security number, does it handle it? Right? What happens if you put code into a field? Does the application handle it? You perform these tests, and then you test the maximum load on the system, right? So you would test for the expected volume, and then you try to find out where does it max out? When does the application fail, right? Because it may hit your desired level, but what happens if you get spikes or you get more than you expect, right? Where you need to know where your application will fail, if possible, and then so you're looking at transaction volume, memory usage, network usage, and then response times. What's an acceptable response time? So there's many trade-offs, because if you're okay with a 1 or 2 second response time, versus a 15-second response time, right? Or 100 millisecond response time. Those will be different sized environments, and it can make a huge cost difference, right? So what response time is adequate, and it's a lot of fun to do performance testing. And then of course you want to keep production or sensitive data secure during testing as well, but you shouldn't be using too much sensitive data in your test. It should be scrubbed of sensitive data, but in some cases you do need to use it, because you need to test appropriately, but you should have bogus data, hopefully. But you're also testing for security as well. Catching vulnerabilities, right? So thoroughly evaluating any change to your environment, formalizing the process, follow the guidance in your data policies, review the system thoroughly throughout its life cycle, ensure it meets its specified security, and then make sure management officially accepts the system. All right, so those are all important, and it's always continuing. Security is continuing to verify and validate that it's still in a secured state. Software development and security, right? So checks user authorization to the application. Authentication, check the user authorization, privilege levels, right? Who can do what, and how many people have admin access or access to sensitive data, or ability to approve purchases or things like that, right? Who's authorized and at what levels, right? And are they appropriate? You have procedures for recovering the database in the event of a system failure, right? Handling errors and exceptions consistently, and does not allow any error or exception to go unhandled. That's really important as far as security, because if somebody were able to enter in something that the system doesn't handle appropriately, are they able to escalate and get authorization or to a higher level? That's where a lot of hacking happens, right? Is in these unhandled errors and exceptions. you need to be able to validate the system itself needs to validate the input so that users aren't able to enter in code instead of a social security number or a password or just regular text input fields, right? So all that input needs to be validated and checked and make sure that it's secured and safe to execute, so it's not escalating the user authorization to a higher level, or giving them access to things that they don't need, right? You definitely need to define the security configuration baselines for an application. And so this is the minimum standard. This is what gets applied all the time and shouldn't change. And then you provide guidance on hardening the application, and you provide for frequent, it should be able to frequently patch and update the application to keep it secure. But I will say that even though you do the frequent patches, even those patches should go through your change management process. It should be a streamlined process, but it should still get approval to apply those patches. Software development models, right? So when we develop software, you have the traditional old-style waterfall model, and that's just one step is completed before you go to the next step, right? So you're in your development, and then you go to your system test, and then you go to user acceptance test, and then you go to production simulation, and then you go to production, right? So you have these defined steps, and one step has to complete before you go to the next step. And that's how it's kind of said to be a waterfall. It trickles down. The Agile development is a much newer style and method, and you're doing smaller pieces. That's the other thing with the waterfall. It's the whole application is moving one step at a time, whereas in Agile you do a lot of the same things, but you do it at a smaller level. It's just maybe you're changing one button's function on one of the pages, and it goes through that whole cycle, and then next and someone else is working on another button, and so they can be at various stages throughout the cycle. But it's more agile, and you're learning, and you're growing, and you're pushing out production development much sooner than the waterfall, because the whole application has to be moved one step at a time, whereas in the Agile you're just taking small chunks of the application and moving it through the process much faster, so you have results sooner. And here's a traditional waterfall, right? So, and like I said, the whole application is moving through these steps, and you get all the way down to installation, and that's when it's in production finally. Whereas in Agile, right, it's continuously going through, and you have these small chunks that are being delivered at each time. And so that is our chapter, and we've covered the IT security policy infrastructure, our data classification standards, and gave examples of organizations and DoD. We definitely went through the change management and configuration management. It's a very important role to security, and as well as keeping the applications up. But from a security standpoint, they're very important. And then our system lifecycle and system development life cycles. So thank you, and I'll see you in the next chapter.